In this video, we're going to look at a linear programming problem and see if we can set up the graph and make a profit equation and find the maximum profit this company can have. So here we have an assembler. They make dune buggies in two models. One's the dune bug and the other's the sand hog. So in fact, in this problem, they've already told us what x is equal to. That's the dune bugs, and then the y is going to be the sand hog. So kind of already gives us an idea of how to set this up. And in the first sentence, they told us that the profit is 120 for dune bugs and 180 for sand hog. So right away we can write our profit equation. 120x plus 180y. And so once we find our corners on our linear inequality graph, that'll be the x and the y value we plug in to find our profit. So let's go take a look at the situation that sets up the constraints. So the company has equipment to assemble at most 60. So they can't make 61, they can't make 62, they have to keep it at 60 or below. So we're going to have that x has to be less than or equal to 60, and we have y has to be 45. So that's physically how many we can make for the x and y. So just recalling, this is going to give us a vertical line right here, and this is going to give us a horizontal line at 45. So that kind of sets up a little window where our solution can be. So let's take a look at the next restraint, our constraint. It says here that it takes 150 hours to do the x and 200 hours to assemble a y. So, but we only have 12,000 hours available. Maybe that's how many employees we have, divided by 40, whatever. That doesn't really matter. So let's go ahead and set it up. We have 150x. Let's see here. We have 150x plus, looks like 200y, and it has to be less than or equal to 12,000. Less than or equal to 12,000. So we have to figure out what the x and the y intercepts are. So using the intercept method, we plug in 0 for y. So if we plug in y equals 0 and solve for x, what do we get? So this thing right here goes to 0, and we can take a 0 off, and basically we have 15x is equal to 1200. And what would that give us if we divide that out? We would get 15 will go into 120. Let's see, 15 times 4 is 60, so it'd be 8. So we have, looks like 80 is our intercept for that. And doing the y-intercept should be a little bit easier. We find the y-intercept, we have x equal to 0, so we have 200y is equal to 12,000. And we can kill off 2 zeros on this one. And 2 will go into 120 60 times. So it looks like we have enough information where we can start our graph, which we'll do on the next page. Let's see what that looks like. So we may have to flip back and forth a couple times. Let's see, so 80 and 60 is going to be our line. Let's go back. So we have x-intercept of 80 and a y-intercept of 60. So we can just jot those down. And y is equal to 60. Okay, let me change colors here. And then we had a horizontal line at 45. And let's go check out our X. Our vertical line is at 60. Okay. X is 60. So that's going to set up our horizontal and vertical lines. So I guess the first thing we have to do is figure out our scale. Probably we could count by fives. This is a 20 grid box, so let's set up our scale. So our X is going to be our dune bugs, and our Y is going to be our sandhogs. And let's see, let's do our 60 line first. So that's 5, 10, 15, 20. So there's 60 right there. And that's going to create that vertical line right there. Alright. And of course, we don't really need to show this right now, but it is less than 60, so we're actually going to be shading over in this direction, right? We'll be shading in this direction. Let's do our Y line at 45. Once again, we're counting off by 5, so we have 45, I believe, is right here. And we have to, we're going to produce what, less than that amount? Let's see what that gives us. I had a little trouble with my pen this morning. Okay, let's go back to the first problem. Make sure that we do have the restraint that we have to produce less than 60 and less than 45 of these two dune bugs. One's a dune bug and one's a sandhog. So just wanted to make sure we were graphing the right area. Okay, the next thing we're going to do is we're going to draw that linear line that we found the intercepts for. And it looks like X is 80 and Y is 60. So we have 65. So there's 80 right there. And we need to label this as 45. 5, 10, 15, 20, 25, 30, 35, 40, 45. Okay, just making sure we got the right values on there. And the y-intercept is 60, so we have 45, 50, 60 is right there. So we'll make a dot there, and make that a dot there, and connect those two dots. Hopefully we'll have some sort of a line there. And of course we're going to be shading back below. So let's identify our intercept. So first of all, we are going to be shading this area right here, right? And it turns this corner here. So there's our shaded region. Our answer is going to lie somewhere in there, but our maximized profit is going to be at one of these vertices. So let's change this to black and see if we can identify these points. So we have an intersection there at 0, 45. Well, we have a 0, 0 really, if you wanted to consider that one. Of course, at 0, 0 we're not going to make any money. We have another intersection here at 60, 0. And we have this equation right here, which we have to figure out. But notice that it's on the vertical line x equals 60, right? That blue line is x equals 60. So we know that into our equation we can plug in 60 for our x value. So let's go ahead and erase this, and let me show you what I've got so far. We've got 60 comma some number, right? And finally, the last vertice is this guy right here, and that occurs when y is equal to 45 because this horizontal line is y equals 45. So let's go back. I've already forgotten what that equation is. Let's go over to this one. It's 150x and 200y, 12,000. Okay. So let me see if I can write that up here. Should have maybe put this all on one screen. We have 150x plus, I already forgotten it. 150x plus 200y, okay. Plus 200y. And it has to be less than or equal to 12,000, right? Alright, so from here we can solve, we can plug in 60 for our x value. Let's do that in orange here. So we have 150 times 60 plus 200y is equal to 12,000. So we have, let's see, 90. 15 times 6 is 90 with 2 zeros added onto that, plus 200y is equal to 12,000. If we subtract 9,000 here from 12,000, we get 3,000. So our 200y is equal to 3,000. And that would give us our y value here. Okay. Looks like this video is starting to get a little bit long. So basically, what are we going to do? Once we find our other x value right here, we found all the intersections, we found all the vertices, we're going to then just plug each of those into our profit equation that we found in the first one, which is 120x plus 180y. So I'll leave that to you. That's just calculations. And what we're doing is we're going to see which one of these profits is the largest value, and that's going to maximize our profit. And that's what we want to do here, maximize our profit. Make the most money we can under the constraints that are part of our manufacturing. So anyway, I'll leave the rest of this exercise up to you. And once you find your max profit, let's say that the max profit occurs at this location right here. Let me make that red so we can really stand out here. Let's say that it occurs right here. Well, that'll be the number of dune buggies that you're going to want to produce. It would be 45 of the sandhogs and, let's see, it looks like 5, 10, 15, 20, probably 20 of the dune buggies. So hopefully you'll get to this point and you'll find the correct answer.